now we're going to get to the point where we actually apply the percent to the real world. And that takes some different approach because percents, as I say, they give you a feeling for something, but they don't give you a precise amount. Half off sale, oh, that sounds good. But how much will I save if I spend $500? I've got to do some calculating to figure out the amount. Okay, so that's what we're up against now. The first approach your book makes for this is percent proportions. So what we want to do is adapt the concept of a percent to the real world situations. Now, this is combining two ideas. One idea is percent, the other one is proportions. Remember, a proportion is an equation. A proportion says that two fractions are equal to each other. So in order to write a proportion down, I've got to write one on the left side, one on the right side. And in doing that, I want to relate it to the real world and to percent. And here's the standard way of doing it. The fraction on the left side is always called the amount in the numerator, and in the denominator it's called the base. And the fraction on the right side is always called p, and that actually represents the number of the percent. For example, if it's 50% off sale, it represents 50. And instead of writing a percent there, what I'm going to do is drop the percent sign and divide by 100. So I get my second fraction by writing the number of the percent divided by 100. So I've gotten rid of the percent sign notation and writing this percent proportion. Okay, now what is the base? Base is a number that describes a whole thing, whereas the amount is a number that describes a part that you're interested in. Okay, now this is not too different from the way we talked about fractions and pizza pies. You know, we said, okay, you can take a pizza pie, divide it into 6 equal-sized pieces, which means the whole thing has the number 6 associated with it, 6 of those pieces. But maybe that only a couple of them are left after people have had lunch, and therefore there are 2 left. So the number you're interested in is those 2. The other 4 are gone. So 2 to 6, all right? Ratio of 2 to 6 gives you a fraction like that. And we're talking about something similar over here. Amount over base is equal to p over 100. Now, the real way to grasp this is to see it in action. Look at a word problem and start doing some calculations with it. So let's take a look. Here's some English sentences and phrases. This one says 25% of 60 students is 15. %, of 60 students is 15. Part of the art of using a percent proportion is to be able to translate that sentence right there and tell where's the percent, where's the amount, where's the base. If you can identify those 3 things in English, then you can get them into the mathematics. Well, of course, the first thing, the easiest thing to figure out is a percent, because it's got a flag on it. It's got a percent sign, so that's obviously the percent. Now, of 60 students is 15. All right, of 60. The number 60 is close to the word of. And that very often happens in English when you're talking about a base. This is the base number. And of course, the only other number in there is the 15, and that's very close to the word is. And this is the amount number. Okay, So if we can identify percent, base, and amount, we can go right to the percent proportion, start doing some calculations and so forth. Let's set that up as a proportion. Might as well go ahead and do it. The amount is 15, the base is 60, and we're saying that's 25. Now we're taking the number of the percent here, because we're dropping the percent sign and dividing by 100. So we've got a proportion there. And the question is it true? Well, the only way to check proportions is cross multiply. We've done that quite a few times. Let's do it. That's going to be 15 times 100. That's equal 60 times 25. This becomes 1,500. And if you do that, you actually get 1,500. That does work. So, yes, that proportion is true. Let's do another sentence so we can get used to tracking down the base and the amount. As I say, the percent is always obvious. 70% of 500 people is how many people? Now we've got a question, which means there's something unknown. And let's see what it is that's unknown. Well, then, right there you see the percent sign, that's got to be the percent. Here's of, and there's 500, so there's your base. So it must mean that this how many people is our amount next to the word is. So let's just call it with the letter A. We don't know what it is, we'll give it a name. That's something we have to get used to because we're going toward algebra. So let's set this up. The amount over the base, well, the amount we don't know, that's an A. The base we've decided is 500 people, and the percent we know is 70. Okay, so that's the percent proportion for a sentence that has an unknown quantity in it. It shows up as a letter in the percent proportion. All right, let's cross multiply. That gives you 100 times A is equal to 500 times 70. And now we work all the zeros here, that's going to be 35,000. And this will be 100A. And we've learned that what you do here in an equation like this to get A is simply divide by whatever's multiplying. So we divide by 100. So A is equal to, canceling out a couple of zeros, 350. So now let's go put it back in this. 70% of 500 people is 350 people. 70%. Remember, 100% is the total thing. So 100% of 500 would be 500. And this is less. This is 70%. So you'd expect a number that's less than 500, and 350 is less than 500. So these work. This is the primary way that that percents are related to the real world. They go through this thing called the percent proportion. Let's look at a few more. As I say, the art here is being able to recognize the amount and the base in an English phrase. $32 is 50% of $64. Well, that makes some sense because that particular percent is an easy one. Remember, 50% of something is half of it. And sure enough, 32 is half of 64, so it does make sense. But let's put it in the percent proportion mode. The amount, again, the amount is going to be close to the word is. 32, that must be the amount. Percent is obvious. The base is over here close to the word of. So you get 32 divided by 64, that's the amount over the base, is equal to P, which we know is 50, over 100. So the claim is that this proportion is true, and actually when you cross multiply, you can get it to be true. This is 3,200 on this side, and 50 times 64 is also 3,200. So it works out. That is a true proportion. As we go further, more and more we're going to be interested in the type which has an unknown in it. So let's go back to that. Let's try another one of those. English sentence which has an unknown. What is 30% of 180? What is 30% of 180? All right, again, identifying parts. Here's the P. The of is next to 180, so that would be our base. Now the what is next to the word is, so that's got to be the amount. Okay, putting it into our formula, what, let's call it A for amount, divided by 180, the base, is equal to P, 30, over 100. By cross multiplying, we'll be able to find out what that amount is, 30% of 180. So that becomes 100 times A is equal to 180 times 30. And this gives you 5,400. Dividing by 100 to get the A. A is equal to 54. So 54 is 30% of 180. Okay? Now, this particular situation, the unknown quantity was the amount, this one right here. But it is true that in various other sentences, you can have a percent unknown, you can also have a base unknown. In other words, you'll always know two, but you're looking for the third one. So let's look at some variations on this where we can see percents unknown and so forth. Yes?
You were not simplifying the 30 and the 80. You waited till later, and it didn't matter. I mean, you could take the 0 off the 180 and the 0 off the 30 and gone that direction. Or
You mean here?
yeah. I mean, well, I mean, you could have simplified, get rid of that 30, make it a 3, make the 180 18. How come you didn't go in that direction to, at that point, simplify?
Well,
to
why
get
would
rid
you
of the
want to
0?
do that?
Huh?
Why would you want to do that?
I don't know. Just less numbers being.
Because it looks like fun? Or
But you can't do it. I mean, right? It's okay.
I would keep it in proportion form.
Still
first.
keep it in proportion.
Yeah,
Okay.
Turn it into proportion form. Now here, at this point, certainly you want to do that.
Right.
You cancel. That's a canceling operation.
Right. Okay.
Yeah.
Canceling out.
Yeah, that's fine.
Oh. Okay.
All right, let's look at this one. 40% of what number is 25? All right, now that's slightly different. First of all, the percent is obvious again. Okay, of what number? Well, the thing that's next to the word of is an unknown. So we'll call that the base B. In other words, we don't know the base here. And over here, next to the word is the amount. Back to the percent proportion, 25 over B, the base, which is unknown, is equal to the ratio of 40 over 100. Okay? So cross multiplying, you're going to 40 times B on one side, on the other side you're 25 times 100, and that gives you 2,500. So dividing by the 40, you find out that B turns out to be 62.5. No, it actually comes out to be a decimal, 62.5. So 40% of 62.5 is 25. So you can get into the decimal region here too, and that can happen very easily. Let's do one with a percent unknown. What percent of 80, miles in this case, is 12.4 miles. Okay, in this case, it's obvious that we don't know the percent, we'll call it P. Of 80, this is your base, and is 12.4, this is your amount. So P over 100 is equal to base, amount over base, which is 12.4 divided by 80. And again, the only tool we have is to cross multiply. 80 times P is equal to 12.4 times 100. 80 times P is equal to 1240 divided by 80. And that turns out to be 15.5. And remember, the P up there is the actual number of the percent, but it's not written with a percent sign. So if you're going to actually report this to somebody, in the case where the percent is unknown, you actually have to put the percent sign on. You get the number of the percent, and it looks like a decimal, but then attach the percent sign. So there's all three cases: amount unknown, base unknown, and percent unknown. So any one of those could crop up in a real life situation. But you can see handling it is very much the same in all the situations. Always look for the base, the amount, and then go right to your proportion. So in other words, this should be on your sheet for tests and stuff like that. Let's look at some applications of it. I'm on page 353. Buffalo, New York receives an average of 94 inches of snow each year. This year, it had 120% of the normal annual snowfall. How much snow did Buffalo get this year? Right, that's three sentences, three English sentences, huh? And it's fine, you know, we know to read them several times and write down the knowns and the unknowns and so forth. But we're going to have to condense this a little bit to get it in better form. Buffalo, New York receives an average of 94 inches of snow each year. This year, it had 120% of normal annual snowfall. How much snow did Buffalo get this year? What's the amount of snow that Buffalo got? We want to put it in an English sentence so we can recognize amount, base, and percent. Okay? So we need one sentence, not three sentences. And therefore, we have to condense this into something that's recognizable. And they do it for you there. The sentence they wrote was, the amount of snow Buffalo received is 120% of 94. That puts all three sentences together. The amount of snow Buffalo received is 120% of 94. And that actually takes all three of them, gets the important data, puts it in one thing. So the amount, obviously we don't know. The amount of snow. We call that A for amount. Buffalo received is 120%. Well, we know that the 120 is going to be the P. And the 94 is the base. And over here you always have 100 underneath the P. That's standard in the formula right there. Okay. Cross multiply. 100 times A is equal to 94 times 120. And then you divide by 100 to find A. And you can put that on the calculator. Let's write down the commands for the calculator, the button pushes. 94 multiply 120. Now, to get this to the division correctly, you should actually start with an open parenthesis like this, and then a closed parenthesis up here, like that. And then divide. See, now it'll treat this as one number, and it's going to divide by 100. And that should give you the following number, 112.8. Again, always ask yourself, is this reasonable? 94 is the number of inches that's normal. We want 120% of it, meaning that we want more than that, because 100% of that would be 94. So 120% means I want the 94 plus more, 20% more. Well, 112.8, that's about right. It's got the 94 plus 20% more, so it does work. Harvard University's freshman class for 2006 had 18% Asian Americans. If this represents 380 students, how many students were admitted to the freshman class? All right, let's see if we can play in our minds with this couple sentences here and get something similar to that. We want one sentence that has a percent, amount, and base in that sentence. %, Asian American students, that represents 380, and out of the freshman class, which we don't know. Huh? Let's see if we can write it down. We could say something like this. 380 is 12% of what number? Does that work?
That's
18%, sorry.
the amount, right? The unknown number is the amount?
The unknown number here, well, no, this is the amount, huh? The amount is right next to the word is. This is your amount. They do tell you the amount. They tell you the percent. But what they don't tell you is the size of the class.
The
In other words,
base.
that percent is based on something. It's based on a class size, and we don't know what that is. So this is the what number. This is the base. Okay, so when we go to our proportion, it looks like this. 380, the amount, is put above the base, which we don't know, B, and that's equal to 18 over 100. So you see, we're having to go through this English sentence thing in order to get the correct things in the correct places for the proportion. And we'll get beyond that, but not right away. So there's the equation. And again, always divide by the number multiplying. So here we go. That gives you just B by itself, and you calculate all that stuff. And it turns out that's a fairly large number. It's to the nearest whole number, it's 21,011, 2,111. Comes out to be a decimal, but you round it because you can only have whole students and half students around. Okay. Now, the next example is really kind of strange. Strange but true. This kind of situation only happens in certain careers. Suppose a tennis pro who's ranked 90th in the world on a men's professional tour earns $280,000 per year in tournament winnings, endorsements, and all that. He pays his coach $100,000 per year. What percent of his income goes toward his coach? Not to the nearest 1/10%. Okay, let's write some things down. 280,000 total income. 100,000 amount paid to coach. Okay, and the percent, we don't know it, so we'll call it P. Percent of total income. Okay, can we see amount and base? Yeah, this is the amount right here. It's even got amount written there. This has to be the base. So let's set it up. Amount over base, which is going to be 100,000 over 280,000 is equal to the percent. We don't know that. P over 100. Okay, there's a lot of zeros there, but that's okay. They'll all drop out. So cross multiplying, you get that. And then, of course, you divide by this. This simply becomes P. Now, we've got a lot of zeros we can cancel out here. All right, so we end up with 1,000 on the top and 28 on the bottom. And let's see what that is. That turns out to be 35.7. Now remember, you're looking for a percent, so it does come out as a decimal, so you have to attach that percent sign. So in other words, 35.7% of his income goes toward the coach. And a lot of people will say, well, that's ridiculous. I mean, poor kid only makes $180,000 a year then. Right, but remember, we live in the United States, which means that's a tax deduction for him. That's a cost of doing business. So he takes that right off his taxes, which means it's a much better situation than it looks like.
It probably evens out. 'Cause
Probably so.
How much would he pay in taxes if he makes
You
$280,000?
you pay a lot of money in taxes. You pay about at least a third of that in taxes. Well, how much is that?
I don't
A
know.
third of 280? That's a little, it's about 90,000 or something like that. Some 80 to
So
90,000.
he gets to take that also. He only has
And he
60.
can simply deduct all of it because he has to pay his taxes. See, so don't cry too quickly for these people. It's amazing what becomes tax deductions, right? All right, so tomorrow we're doing 4.5 through 6.2. I'll put some homework up here for section 6.3, but this will only be when we come back after the vacation. Remember, there's a week-long vacation next week. If you come here, you will have lots of parking Don't forget to have your homework ready when you get here. If you take it at supportive services, be sure to go over there.
You can just look at my.
Excuse me, let me just make this announcement because people forget this. Hello? If you're going to supportive services, go over there and remember to put your homework in the same test envelope as the test. And that way it's back in the day.